Good morning, good afternoon, or good evening. Whatever time you're watching this educational video, today we will have to do one problem related to uh, work and power. As we all know, these two variables are connected. In order to rate the work done, we should have to know the formula to get power. And don't forget to get the formula of work. It's FD cosine theta. And to get power, there are many ways to do it because we can incorporate the work is equal to change in ME. And remember, ME is equivalent to kinetic energy plus the potential energy. So you can have a lot of formulas to get the power. Power is the rate of work, meaning to say P is equal to work over time. Or we can just write ME, change in ME over time, or change in kinetic energy over time, or we could also have potential energy over time. Okay, and if velocity or the average velocity is provided in the problem, get the force and you will get the average power or the power itself, as power is also be calculated when you have force multiplied by the average velocity, or force multiplied the average speed. Okay, so much with that. Our video for this moment, you will be getting the a variable not via mechanical energy or conservation of energy, but this time we are using our kinematic equations in calculating the unknown variables. We will be using kinematics today. Okay. Now let's have the problem. But before that, of course, hit like, and if you like this content, yeah, or feel free to subscribe. This is our problem. During holiday, the main road is free from other vehicles. A rider whose mass of 40 kilograms, and that includes the mass of his big bike. So all in all, the total mass will be 40 kilogram. I will box it so that we can easily remember the value of the mass. And this time the vehicle moves from 20 meter per second, like the q here is from. So therefore this gonna be our initial velocity, our vi, to a certain velocity, and I guess it's gonna be the unknown. We don't know it yet, we need to calculate it at 50-meter distance. So the displacement or the distance is provided, and of course we have to ignore or to neglect air resistance and the kinetic friction of this particular system. And these are our tasks for this video. Let's figure out magnitudes of the following. We need to calculate the final velocity and the seconds it takes to reach 50 meters. So we need to know the time. And a horsepower. Horsepower is another unit of power, of course, expended in that particular second. Okay, assuming that the amount of force expended by the engine of that bike is 30 newtons. So, yeah, we're all set. We have the needed variable to calculate our problem. Okay, let's do it now. I will try to write the given variables here. The first one, if I'm not mistaken, we have the total mass of the system. That's 400 kilogram. And then we do have the force of the engine. And I forgot, hold on. It's 300. Okay, it's 300 newtons. Then we have the initial velocity from 20 meter per second. And what else? We do have the displacement of our system. It's 50 meters. Okay. And let's try to find out what else here. We're done. Right, we're good. These are the given that we can use in calculating the unknown, which is the final velocity. So before anything else, we cannot calculate horsepower without the time, right? So we need to get the seconds in order for us to get the power in horsepower unit. Okay, so before we will calculate the other variables or before we can get the final velocity, we should use the Newton's law, especially the second law, law of acceleration, which tells us that to get the acceleration, all you have to do is to divide force by the mass. So we have force of the engine. We will plug in here. We have 300 Newton, then divided by our mass of 400 kilogram. Yeah, we should need the acceleration to be calculated first in order for us to substitute this acceleration to other kinematic equations so that we can be able to substitute the value of our acceleration in uh, one of the kinematics to get the final velocity. We have 300 newtons divided by 400 kilograms. We have 0.75 meter per second squared. So that's the unit. I would like to show how the unit is being, derived, because remember Newton could be written as kilogram meter per second squared, and we will divide it by the kilogram here. So kilogram will be cancelled and the remaining unit will be meter per second. Okay. And we already calculated the acceleration, so we can substitute the acceleration in our next step. Our next step will be trying to find the best kinematic equation in order for us to get the final velocity. So try to think of the best kinematic equations in order for us to solve our problem today. Find the VF. So in my head, I would like to use this formula here. VF squared equals VI squared plus 2AD. And we don't have the final velocity, but we have the initial velocity in our problem. It's 20 meter per second. Don't forget to square it out. 2 times our acceleration, we just calculated it. It's 0.75 meter per second squared. And then times our displacement provided in the problem, 50 meters. So let's do the math. 20 times 20, it's 400. Then the units do the same, meters times meters, meters squared, seconds times seconds, seconds squared. And then we will try to get the product of 2 times 0.75 and 50. And the answer for that will be 75. Look at the unit. No cancellation of unit here, but instead we have meter times meter. We have meter squared and then second squared. It makes sense because we need to have the same units in order to operate. We have meter squared over second squared. Both units are the same, so we can calculate it. 475 add 475 meters squared per second squared. And if you notice, our variable is in squared, so we need to get the square root of each side. Square root, square root. We can cancel the radical sign here, leaving our VF alone. And to get the square root, we can have to cancel the radical and these squares here. VF is equal to positive, negative 21.79 meter per second. But according to the problem, we need to just get the magnitude of it. So the positive value will do. So this is our final velocity using the kinematic equation. We use the second law first to get the acceleration, and then to get the VF, we use this formula. Okay, we're not yet done. We need to find the time to get the seconds. The seconds spent in the system. So we have our acceleration is equal to 0.75 meter per second squared, and then we have the final velocity of 21.79 meter per second, if I'm not mistaken. Okay, so we need to find the seconds spent here, the time taken for this system to move all the way up to 50 meters. So the easiest formula in kinematics, we can have VF is equal to VI plus AT. And we have the time variable here in order for us to get the time. So let's substitute VF. We calculated it seconds ago. We have 21.79 meter per second equals the initial velocity of 20 meter per second plus our acceleration 0.75. It's here, 0.75 meter per second squared. Then the unknown time. Okay, so we will subtract 20 in both sides. So we can have 20.79 meter per second minus 20 meter per second. So 20 will be cancelled. So in the right side of our equation, so we can have 0.75 meter per second squared times the time. So hold on. It must be 21.79. Let's continue. So 21.79 minus 20, we have 1.79 meter per second positive. Then in order to isolate our time variable here, we need to divide both sides by 0.75 meter per second squared, or the acceleration meter per second squared. So cancel. Time will be 2.39 seconds. I just want to show how we derive the unit of time. Remember, meter per second divided by meter per second squared. And if we will divide fraction, we will make division into multiplication and the reciprocal of our denominator. So s squared mass cancel, 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 and then cancel this one. We have the remaining second units. All right. So the last thing to do is to find our horsepower, or the power. We already have the time. That's the perfect formula for us to complete this problem. Number 4, we need to find the horsepower. Okay, so power, if you could still recall, that's work over time. And work there, we need to have FD over time. So the force, if I'm not mistaken, the force is 300 Newton. 300 Newton and then 50 displacement. Over the time, we just calculated it. Let's plug in here, 239 seconds. Then 300 times 50 newtons, we can have 15,000. Let's put it here, 15,000 Newton meter over 2.39 seconds. And let's divide 15,000 by 2.39 seconds. The answer is 6276.15. The unit is Newton per second, or watts, or joules per second. Okay, so we will convert. I will erase some parts here. Okay, for focus that I put the continuation of our solution at this part. Can I use an arrow here? Okay, so I will be copying the answer, 6276.15 Newton meter per second, and we will convert it into horsepower. How? 1 horsepower is equivalent to 746 watts. And watts is just the Newton meter per second or joules per second. So Newton meter per second is just the watts. So we can plug in here Newton meter per second. It's 746. That's 1 HP. That's our desired unit in our conversion factor. So we can cancel Newton meter and we have the remaining unit. Okay. And our answer, we will divide 6276.15 by 746. And the answer will be 8.41 horsepower. This is gonna be our final answer. All right. So if you enjoy this content, of course, do not forget to subscribe to this channel. If you have a question, you can comment down below. And of course, don't forget to like if you like this content. Thank you so much, and see you until next time. Bye for now.